Unit 6, Lesson 3, we are learning about factoring algebraic expressions. The essential question for today's lesson is, how are distributing and factoring related? So we need to know what that means. All right, so let's go ahead and start. Elementary school reminders. Now we know that we all forget elementary school things, or maybe we didn't quite learn them. So let's take a look at these two things at the top before we begin the main part of the lesson. The first part says the greatest common factor, the GCF. Now, how do you find the greatest common factor of 12 and 18? Well, you're coming from a bunch of different sixth grade classrooms, and so maybe you were taught different ways. So the greatest common factor is numbers that go into both. So if we list out our 12 right here, and then we put all of the factors that are into 12, that would be a 1, a 2, a 3, a 4, a 6, and a 12. Those are the factors of 12. All of those numbers go into 12. And if we were to list the factors of 18, we have 1, 2, 3, not 4, not 5, but we have a 6, we have a 9, and we have an 18. Those are all the numbers that go into 18. Okay, so which ones do they have in common? So we listed out the factors. I'll highlight the factors. There they are. These are all factors of 12. These are all factors of 18. And now which do we have in common? Which ones do we have in common? So we have 1s in common, we have 2s in common, we have 3s in common, and 6s in common. Is there anything else in common? No, there's not. And so now of those, we are going to pick the greatest of them. Now the greatest one is 6. It's hard to see my highlighting, so I'll circle it. 6 is the greatest common factor. So down here we have these line times a line equals a product. So we're going to say factor times a factor equals a product. So that's something to remember what a factor is. So GCFs can only be a positive number. They cannot be a negative. Only positives. All right, now that's your reminder on greatest common factor, but there's another one we learned from elementary school, which is the least common multiple or least common denominator. And sometimes we get the two confused because they're on two totally different days. So let's look at this one and find out how to find the LCM or LCD of 12 and 18. So we'll list the 12 here, and then we just count by 12s. We say 12, 24, 36, 48, and we just keep on going. It's going to go to 60, and it never stops. It just keeps on going. There's unlimited amount of multiples of 12. Then we list 18, and our 18s are 18, 36, and I can stop right there because we have already found the least common multiple. So let's go ahead and know what multiples are. Multiples are all of these. It just keeps on going on forever. And with 18, we can see that it keeps on going on forever as well, but we stopped. The reason why we stopped with the 18 multiples was because we saw something that they had in common. What do they have in common? They have 36 in common. I'm going to highlight 36. Do they have any others in common? They probably do way down here, but we're looking for the least. So as of right now, we started with multiples, or you could have said denominators if you're talking about fractions. Then we talked about having something in common, and that was our 36s are in common. And then finally, we're looking at least. So what's least? Well, 36 is the least common multiple. All right, so that's called the LCM. Multiples are blank or equal than the numbers, okay? They are bigger or larger or equal than the numbers given. So we're talking about 12 and 18. How would they be equal? Well, if you were talking about 12 and say 24, you can count by 12s, 12, 24, count by 24s, and you can see that that 12 is equal to that 24 is equal to the 24. That's why we have equal there as well. Now, LCMs can only be a positive number. So those are the same as the GCFs. So we're going to be working with these today, the greatest common factors. All right, let's go down to the next part. Distributing and factoring relationships. Now, this is a key thing right here. I'm going to highlight this because it addresses something up above, the essential question: how are distributing and factoring related? And this is where you're going to find some of your information. Dividing an expression back into a product is called factoring. Okay, we have two flags here with arrows. In this flag right here, we have 2x plus 8. This is considered simplest form. Now, we learned that in a lesson previous. Simplest form is simply no like terms and no grouping signs or parentheses. I'm going to put grouping signs. Okay, so that's what simplest form is, and that has no like terms and no parentheses. Now, if you take this one in simplest form and make your arrow going this way, okay, that is called factoring. We're going to change this into this, what we already know. That's called factoring. Okay, and this one, this says 2 times the quantity of x and 4. So this side is called the factored form. So when you're factoring, you're making it into the factored form. To go back from the factored form back to simplest form, you learned this just a lesson ago. It's called distributing. Distributing. Okay, so fit it in there. My pen ink is a little too thick. I need to change that. All right, so let's go on to this bottom part. If the distributor property uses blank, then factoring must use blank. So what did we learn about the distributor property? We wrote it in the summary this last time. We said that the distributor property uses multiplication. So if distributor property is using multiplication, what do you think factoring must be using then? Must use division. Okay, so now we know the relationship back and forth from factoring and distributing. Okay, let's find out a couple different ways to learn how to factor an expression. And in the margin here it says factor an expression means, what does it mean? It means reverse distributive property. What was the reverse of multiplication? The reverse was division, right? So you can only imagine we're going to divide. Now it's most likely in 6th grade or 5th grade or even 4th grade, you probably were practicing this one called the factor tree. Okay, so what is the factor tree? Let's take a look. All right, here we go. So factor tree looks like this. Put little sticks underneath it. That would be the top of the tree, and 16x would be 16 times x. And then you look to do that again. 16 is actually, you could say 4 times 4, you could say 2 times 8, you could say whatever you want. But we're going to do 2 times 8, and then 2 is going down to 1 times 2. 8, however, is 2 times 4, and 4 is 2 times 2. Now, I ran out of room here, but what we want to do is look for the end of the road. And so we can see we didn't have to go down to the 1 times 2. 2 is a prime number, so we stop there, okay? And then we have a prime here, a prime here, and a prime here. We do not want to do these composites, okay? We don't want these. We want the prime numbers when you get down to the very nitty-gritty of the number, okay? So we have that. And now we're going to do the prime factorization, or the factor tree of 24. So I'll make this a little shorter. This could be anything you like. Let's say 3 and 8. 8, as you know, is 2 and 4 is 2 and 2. So the prime factorization for 24, that's a prime, a prime, a prime, and a prime. So now we have our listings of the prime numbers from the factor tree. So then what you do is you list them, okay? So 16x and 24. So 16x is 2, 2 times 2 times 2 times 2 times that x. So we list them out. 2 times 2 times 2 times 2 times x. All right, and then we're going to do 24. And we list them out. It's 2 times 2 times 2 times 3. 2 times 2 times 2 times 3. And then I'll change colors here. Or no, I'll do a highlighter. I am going to find ones that they have in common. Okay, the ones that they have in common. Okay, are these 2's, these 2's, these 2's, and they have nothing else in common. So what you do is you take your common ones and you just go 2 times 2 times 2, and that is equal to 8. So 8 is your GCF of 16x and 24. Okay, so what do you do with this? Well, you take it out, you say 8 and 16x. How many 8s are in 16x? 2x of them. How many 8s are in 24? There are 3 of them. There's a plus sign there. And so then you say, oh, there you go, finally got to it. But here at Alta Sierra, we like to teach the upside down cake method. You're going to like this. So what you do, you put an upside down division sign like this. Okay, it is upside down. It's a division bar. We're going to work down because it's cleaner. All right. And then you can say, what kind of common factor does 16x and 24 both have? Well, they are both even numbers. And since they're both even numbers, you can say, 2 goes into both of them. All right, 16x divided by 2. How many 2's are in 16x? There are 8x of them. Okay, then we go on to 24. 24 divided by 2 is 12. Bring down that plus sign. You add another layer of the upside down cake. That's where we get it from. Looks like a wedding cake. And what can you take out of 8x and 12? Well, you can take out a 2. How many times does 2 go into 8x? It goes in 4x times. And 2 goes into 12 6 times. Bring down the plus sign. And then you think, well, look at that. They're still even. I can take out another layer of cake. 2 right here. 2 goes into 4x, or 4x divided by 2 is 2x. And 6 divided by 2 is 3. And then you say to yourself, well, is there anything else I can take out of 2x plus 3? And there is no other common factors in those two numbers. So now here comes the nice part. You put parentheses around it, and then all you do is you take these that are right over here and you multiply them together. Well, 2 times 2 times 2 is 8. And look at that. right here. You have the answer. It's way faster, it's cleaner, it doesn't get so jumbled up and messy, and we are just really offering this to you to make things easier. Okay? So which method will I use? For me, I'm going to be using method 2. Oops, I spelled it wrong. Let me try it again. Method 2. Why? I'm just going to say it's easiest. Now you might not think it's easiest first because maybe you're used to the factor tree and list the prime factors, but I'll tell you what, you can tell there's a lot less writing on the method 2. All right, let's practice what we've just learned. Okay, we have 6 we-dos. So by the time we get over with these we-dos, you're going to turn the paper and you're going to start doing them on your own. So this is called the upside down cake method. So we're going to use an upside down division bar. And those are both even numbers, 2x and 6. They're both even, so we know a 2 can go into both. And 2x divided by 2, well, what's 2 divided by 2? It is 1. That x comes down, and 6 divided by 2 is 3. Now, is there anything else we can take out of those? No. But do we need the 1 in front of the x? Well, 1 times x, or 1 times anything, is itself. So I'm going to rewrite this as x plus 3. I'm going to put parentheses around it because I'm done. And I'm going to find my GCF, which is right here. I only have one number, and 2 is 2. Now, how do I know I am correct? Well, if you distribute, 2 times x is 2x, and 2 times 3 is 6. And I have the plus sign. So that is correct. I'll highlight it, saying that that is my final answer. All right, let's try B. My upside down division bar. I have a minus sign now. That's okay, we'll leave it there. And 6h and 9. What number can go into both? If you're thinking the number 3, you are correct. 3 goes into 6h 2h times. 3 goes into 9 3 times. Bring down the minus sign, and there is nothing else we can take out of 2h and 3. So I'm going to put the parentheses around it. I'm going to find my GCF, which is just the 3, and there you have the answer. Okay, how do you check? You just do distributive property. 3 times 2h is 6h, and 3 times 3 is 9, and there's the minus sign. It's all good to go. Okay, now for the next one. Upside down division bar. Now we have some larger numbers. We have negative 40g plus 24. They're both even numbers, so I'm going to take the long road here. There is a faster road. The bigger number you can put here that goes into both, you'll be done faster. So let's go ahead and try a 2. Okay, 2 goes into negative 40g. Think about this. Negatives divided by a positive is negative 20g. And 2 goes into 24, or 24 divided by 2 is 12. Bring down that plus sign. Add another layer because I can take out more. And I know that because they're both even numbers. And I know that I can take out 2 again, but I also know I can take out a 4. And the larger common number you can use, the faster it will go. So 4 goes into negative 20g, negative 5g times, because a negative divided by a positive is a negative. And 20 divided by 4 is 5. 12 divided by 4 is 3. And is there anything else I can take out? There is not. So I put parentheses around it, and then I multiply these numbers over here. 2 times 4 is 8. And this is my answer. How do I know? 8 times negative 5g is negative 4g, and 8 times 3 is 24. All right, we just have 3 left as we're learning here. Hopefully you're getting the hang of it. If not, you can rewind the video and look back at what's going on. Remember, it's about learning and not copying. All right, so let's add our division bar. Now we have a negative in the front and a minus sign. No problem. What can we take out of both 12 and 16? Well, if you're thinking 4, that would be a great thought. If you're thinking 2, that's a fine thought too, but remember, the higher number that you use that can go into both, the faster the problem will be. All right, so negative 12x divided by 4 would give you negative 3x. And 16 divided by 4 is going to give you 4. Bring down that minus sign. And there's nothing else we can take out, so we put the parentheses around it. And then we take our GCF and put it in front. To check, remember, you can do distributive property. You can see that's going to equal the beginning. All right, let's go ahead and try this one. Here is our upside down division bar. And this time we have an A and an A. So I want you to learn what do we do on this one. 32 and 24. What number can go into 32 and 24? Let's take the long road on this one. Let's say they're both even, and you say 2. So 32a divided by 2 with the calculator is going to give you 16a. 24a divided by 2 is going to give you 12a. Bring down the minus sign. Then you make another layer of cake. You see they're even numbers again, so you say 2 again. 16a divided by 2 is 8a, and 12a divided by 2 is 6a. Bring down the minus sign. We make another layer of cake, and we're taking out 2 again. 8a divided by 2 is 4a. 6a divided by 2 is 3a. Bring down the minus sign. Now, there's nothing we can do with the numbers anymore, but they both have an a. So now you can factor out the a. 4a take away, or not take away, but 4a divided by a is actually 4. You took that only a away from it with division. And 3a divided by a is 3. Bring down the minus sign. Okay, so we're almost done right there. But we can simplify this. What is 4 minus a? Why can we simplify? Because they are like terms. That is 1. Put parentheses around the 1, and then find your GCF. Okay, that's 2 times 2 times 2 times a. And 2 times 2 is 4, 4 times 2 is 8, and 8 times a is 8a. So 8a times 1. Now if you add 8a, 4 minus 3, and you checked it, you would have what you started with. I apologize for taking it so deep. Hopefully you can fit it on your paper. This one will probably go deep too, so that's a warning. We're going to put this cake right here, and we're going to try not to go deep. We're going to try to do this all in 2 layers. So negative 33 plus 77EF. So it looks like 11 can come out. Negative 33E divided by a positive 11 is negative 3E. 77EF divided by 11 is 7EF. Bring down the plus sign. Make another layer. They both have E's, so I'm going to factor out an E. Negative 3E is negative 3. And 7EF, factoring out an E, is 7F. All right, looks like I'm finished, so I'm going to put my parentheses around it. And 11 times E is 11E. You can always check it with distributive property, and you'll see that it is equal. All right, that was a lot of practice. We have a couple steps to factoring here. Let's make sure we know what they are. So what have we been doing? Well, we find a common factor first, okay, for each term. Use upside down cake method if you want to. If you don't, that's fine. You can do your way as long as you're getting the right answers. Number 2, divide each term by the common factor. It's also called factor out, and leave the remaining factors in parentheses. And number 2, check your work with distributing, and we did that every time. All right, now it's the you-dos. So go ahead and pause the video and try G right now with upside down cake method. Pause now. Okay, there's the answer. So remember, this 1 times x right here is actually just x. So remember how to check this? This is step 3. 3 times x and 3 times 3. Is it what we started with? Sure is. Pause the video and try h now. Okay, here's the answer. I got a 4. I took a bigger one out. You might have done a 2 and a 2. Well, 2 times 2 is 4 as well. So to check your work, you're going to distribute. Try I now. Pause. All right, the answer is 15 times the quantity of 6c plus 1. How do we know we're right? Well, we can always check going backwards. 15c, 15 times 6c is 90 c's, and 15 times 1 is 15. Pause the video and try J. Here's your J answer, 5 times the difference of 2x and 3. Remember, use your distributive property to be checking your work. And that is same thing as 10x minus 15. Now you're going to pause the video. You're going to try K and L at once. Pause now. All right, there is K and L. And remember to always check your work using the distributive property. All right, well that does it for factoring. You guys know how to do this now. If you don't, remember you can always rewind, and maybe you were just caught yourself copying, you weren't really listening, so you can go back and see how to do it. Now for the test readiness checks. These are important. As you know from the very first unit, when you do these, we are showing you different problems that perhaps or will be on the tests coming up, and that's why we call it a test readiness check. And these are all you-dos. So you can see they go through. Some of them are going to be easier than others. Some of them are going to have to make you think. All right, so go ahead and try both P and Q since they're both factor and factor. It's what we've been doing with the upside down cake. Pause the video and try those now. Okay, we're back with the answers, and take a look. Did you get them right? By now you want to be getting them right for sure. Okay, so make sure that you have distributed property to know that you are getting what you started with. Okay, we're going to go over to R now. Now R is a little different, so let's go over it before you begin. Here's R. It says which expressions are equal to 8v plus 16. So we have yes or no boxes, and you have to find out which one of these, there might be more than one, that is equal to 8v plus 16. Now you might want to start off by doing your upside down cake method and find out the answer, but there might be other ones here that are also equal to this one. So pause the video and try it out. Okay, we're back with R, and I chose, instead of doing the cake method, because if I did the cake, I would take out 8. That would leave me with 1v plus 2, and I know that's v plus 2. I would put my parentheses around it. I would move my GCF in front, and that only gives me one answer. That's it, one answer. And that would be way down here on this one right here. 8 times 1v, or v, plus 2. So I'd say yes. And I might, just because of that, say no to the rest. So I use the distributor property here. Okay, and I multiplied all of these, and I found out, look at that. This one right here is actually 8 equal to 8v plus 16. This one's equal to 8 plus 16v. The v is on the wrong number. That's a no. This one's 8v plus 16. That's another one that works out. And this last one is 8 plus 16v. V is on the wrong number, so that's a no. So you really have to think through those things so you are not picking the wrong ones. All right, it is time for S. Here's how S works. Select all, okay? On a test, that all would probably be bolded, maybe even underlined, so you guys see it. Select all expressions equivalent to 8a minus 32. All right, so you can see a bunch here, okay? And you want to know which ones are equivalent, okay? So there's different methods to do this. You could do the cake. And find out what that is. But look at all the different numbers out in the front. There's 8, a 2, a 4, a 4, a 2, and an 8. So you know if you do the upside down cake, you're going to get one of these probably. Okay? But you're not going to see the other answers just like on R. So probably the best way to do this is do your distributive property, okay, for each of them. Pause the video and work your way through it and find out which ones are equal to AA minus 32. Pause now. Okay, we're back and I did distributed property to every single one. Now I want to be careful in choosing which ones are equal to 8A minus 32. This one's definitely not. Neither is this one. That's 6A. That's just indicator already. 8 minus 32, so this is a good one. This next one has 16A, definitely not. We have an AA minus 32 right here. That's another good one. And this last one almost looked good, but we're missing something. What are we missing? We're missing the A. Notice it's not there. So if you chose that one, that is wrong. Okay? So there's only 2 of the 6 that are equivalent. All right, now it's time to simplify this one. Now remember, simplify, there should be no parentheses and no like terms. Pause the video and try it out. All right, I'll explain this C team, JV, and varsity in a little bit. Let's take a look at what we're doing. We are distributing -11 to the 2 to get -22, and -11 to the 3c to get -33c. This is a plus sign, so we did move it down. Now that is the right answer. I'm going to say that that is a C team answer. It's good. It's right. You're playing the game. It's good. But let's look. How do we move up to the JV level? Well, when we write our answers, we want to have our variable terms in the front. And since this is addition, we can move things around with a commutative property. So we're going to move -33c to the front, just like these arrows indicate. And then we're going to move -22 to the back. And we're going to have the plus sign right there. So that is also correct. Now this is better because the C term is in the front and the constant is in the back. That's a JV level answer right there. Now if you want to go all the way up to varsity status, you're going to have to keep this -33c, and you can see right here, this is adding a negative is the same thing as subtracting a positive. How do we know that's true? Well, if we did additive inverse to this, look, it looks identical to the JV answer. So varsity answers have less symbols and signs and look cleaner. So I'm going to do the back arrow. Okay, we are back. Tough problem, isn't it? Let's find out a good way to solve this based on what we learned today. Well, we learned about factoring, and this 10n plus 7n is the simplified form of this, what's it called? Factored form, okay? So let's go ahead and set this up like this. And you can see that 10 plus 7n, there is nothing we can take out down here. But we can see that the answer is 5 plus 3.5n. I'm going to use that to write down here 5 plus 3.5n, and that is supposed to be the answer. Okay, so how would we get a 5 down here? What would we have to divide 10 by to get a 5? what would we divide 10 by to get 5? It would be a 2. All right, let's see if that would work here. What is 7n divided by 2? Or 7 divided by 2 is also 3 and 5/10 n. So it looks like it's working. So this would be our GCF. So we put a 2 down there. Now look back at this problem. This part right here, inside the parentheses, is the exact same as over here. And outside in front of the parentheses is p. And outside in front of this one is 2. So what is the value of p? P is 2.